Hello, and welcome to another conversation with Carl. Please like, follow, and subscribe for the latest content. Today, I'm joined by Professor Jim Bell, a planetary scientist, space explorer, author of one of the key minds behind how we actually see other worlds. As a professor at Arizona State University School of Earth and Space Exploration, he helped lead camera teams on NASA missions to Mars, capturing the images that have shaped how humanity understands the red planet. But beyond the tech and the titles, Jim is the storyteller of exploration. His book, The Art of the Cosmos, turns distant alien landscapes into something vivid, human, and deeply meaningful. Welcome, Professor Jim Bell, to the conversation.
Thanks for having me on, Carl.
Thank you for doing this. So, my first question, what does space exploration mean to you?
Oh my gosh. Let's start with a small question, shall we? Well, space is literally the final frontier, right? And it's where we push ourselves as a species to learn more about not only our planet, but the planets around us, the stars around us, the galaxies around us. It's the way that we manifest much of our science and technology into exploration. It's always been the human way, right? I mean,
Yeah.
there's always been a frontier, there's always been a distant hill, a horizon that we've felt compelled as a species to explore. And so partly it's innate, right? It's something that we do because it's built into us. And that's super exciting. The other thing that's exciting is that partly now it's an economic imperative. Right? And getting
Yeah.
into space is part of at least low Earth orbit is part of the world's economy, geostationary satellites, weather satellites, communications, international finance. It's like space is becoming more and more part of our everyday life.
Were you surprised by Artemis 2's how everybody was so fascinated by this?
No, I was delighted, actually. I was delighted. I remember the lead up to Apollo 11, but I remember the later Apollo missions, and I remember watching the astronauts drive cars on the moon on TV when I was a kid and thinking, wow, that is just the coolest thing. It didn't need narration. It didn't need explanation. It was just like, this is a dangerous thing. This is a really cool new thing. This is people going into places where we've never been. And all of that was kind of recreated with Artemis 2, right? I mean, Artemis 1 was a very successful mission, but nobody was on that rocket, right? And so it wasn't the visceral feel of, wow, people are in danger. Brave people are putting their lives at risk to test this system so that people can go back to the surface of the moon. And so that tension, those stories, those human stories, I think are what compels just general interest in our society in space exploration.
I mean, I was fascinated looking at the pictures and watching them, and I kept thinking to myself, where are we going next?
Yeah. Well, it's the Artemis 2 was a pathfinder for future missions, testing a lot of these systems, life support systems, propulsion systems, all the computers. The astronauts themselves were guinea pigs in a sense. They were the first people in more than 50 years to leave the protective cocoon of the Earth's magnetic field and get exposed to the real radiation of the sun and deep space. And so they were poked and prodded with modern medical technology, the first people to be poked and prodded with modern technology in deep space. And so, they were setting the stage for what comes next. Is what NASA has announced is Artemis 3 will be an Earth orbital mission to practice docking with the lunar landers built by SpaceX and Blue Origin. They need to get tested. And just like in the Apollo missions, Apollo 9 was a test of docking and maneuvering in Earth orbit to connect the then Northrop Grumman lunar module to the main command service module. And so it's kind of following those footsteps, iterative little baby steps. Let's test that next system. And then the idea is that Artemis 4 will send people down to the surface somewhere near the South Pole of the moon where there's potentially ice resources, where there's places of daylight all the time on some of the ridges there for solar power, and where everyone's envisioning, kind of like Antarctica, will build some kind of a base to establish a foothold off the Earth.
When does this happen?
Yeah, that's a great question. I've been asking myself that for 50 years. When does this happen? The schedule for what I just talked about, Artemis 3, Artemis 4, is over the next 2 to 3 years. That's the schedule, and Obviously, the engineers and others at NASA are poring over the data from Artemis 2, seeing what lessons learned, seeing if anything needs to be changed and fixed and updated, whatever. That could get pushed out, I suppose. But this administration really wants a moon landing before the end of 2028, right? And so there's
Well,
pressure to do that.
just a question that I had when I was watching and they were coming back to Earth. They were going 25,000 miles an hour as they re-entered the atmosphere. What does that feel like?
I mean, they were traveling almost that fast the whole way, and you
Oh,
didn't feel anything because they're weightless, right? They're
yeah.
essentially falling in an orbit around the Earth. And so it wasn't until they started getting very close to the Earth and started decelerating and
Okay.
started slowing down, that's when they felt the G-forces. I don't know personally what that feels like. I'd love to learn someday, but it's something like 5 Gs or more. So it'd be like, when your airplane lands on a short runway and the pilot hits the brakes and you're kind of, so they're all
Yeah.
strapped in and they're feeling that, 1 G or 1.5 G on the runway that we've experienced. Now multiply that by 5 or more.
Yeah.
And so, comparable probably to what fighter pilots feel in a tight turn and things like that, and so, but it's all controlled, right? The human
Yeah.
body can only take so many G's. And so they controlled it and they all survived just fine.
They did. In your book, The Art of the Cosmos, you look at the intersection of space exploration and art. Can you tell us about some of the magnificent imagery we've captured from space?
Yeah, this was a fun book to write, Carl, and also a bit challenging because many of the pictures taken in space exploration are just kind of routine. We need to document this. We need to count the number of rocks on the side of that hill on Mars, or we need to figure out where to drive this rover, or we need to look at what those clouds are like in this planetary atmosphere. They're typically you just take them because you need to, because you've only got so much time and whatever. But occasionally colleagues who do this for a living have a little bit of luxury. They can think about framing something, thinking about depth of field, thinking about, near and far focus, thinking about color, right? Occasionally you have the luxury of sort of acting like photographers typically do in the photographic art world. And so I tried to find a bunch of those kinds of examples, right? There was one of the Apollo astronauts, for example, of course, they were very scripted when they were on the moon. Every moment was exactly from a script in Houston that they had to do this. But one of them brought a picture of his family, a color picture of his family. He took it out of his spacesuit pocket, put it on the surface of the moon, and took a picture of it with his camera.
Yeah.
And, like, I forget the colors, but, his wife is wearing a red blouse and the kid's wearing a blue shirt. And the moon is like just this study in black and white. All it is black and white. There's nothing
Yeah.
green or blue on the moon, right? And yet this is color picture in stark contrast to the grays. And it was just also just a poignant moment. It wasn't in the script,
Yeah.
It's like nobody's going to stop him
Yeah.
from doing that. And yet he thought, hey, I am just an awareness. I am so far away from home. Nobody's been this far away from home. I miss my family. Here they are with me. I'm going to leave them here on the moon. I mean,
Yeah. No, that's
yeah,
a great story.
yeah. But there's a whole bunch of examples all over human exploration from Apollo, from the shuttle, from other missions and robotic exploration too. And it's a little challenging in robotics. Sometimes you're just flying past something and you get one shot and you just got to, you're like a tourist driving past the Grand Canyon. Imagine that, right? And you got to take as many shots as you can. But again, occasionally, maybe luckily or maybe by planning, you can get something that is beautifully framed, like, the big moon Titan around Saturn with a smaller icy moon behind it. And then in the distance, the plane of the rings of Saturn and the yellow orange ball of the planet itself. I mean, just like, wow, that's
Yeah.
amazing. Hollywood couldn't write a better script for an incredible landscape photograph, right?
How does AI play into this in the future?
That is a great question. Nobody knows, but there are lots of aspects to space exploration that are relatively routine. Some of the data processing, some of the orbit planning, some of the testing. And, people do that because you need eyes on, and especially if human lives are at stake. Maybe more so in robotics, there's a number of things that can be automated. The automation side of it is already uh, progress is being made to do that. But then there's a bunch of people, colleagues who are thinking about, what if we were to send a space probe, a lander, a rover, an orbiter, people around an asteroid, something, out there. And we we're pretty far away, so we don't have a lot of communication bandwidth. There is no internet in the solar system yet. So we can only send a trickle of data, soda straw data back to the Earth, but we can take a lot more data on the spacecraft with instruments, cameras, spectrometers, other kinds of science instruments. So what if we could process that data? Or what if we could take a bunch of data that we know we can't send back to the Earth, but have an algorithm? We've typically called it machine learning. Now people are calling it AI. Take an algorithm and sweep it over that and say, okay, send me the most interesting stuff out of here. Send that back to the Earth. And the rest, lower priority. If you can get it, you can get it. But what did you just see? See, in quotes, algorithm designed by people on the Earth. We were looking for XYZ. Did you find it? Send that back. So I think those are the kinds of near-term things that AI can be doing.
But you get yourself into trouble there because you don't know what's out there also. So
You
when
don't
you're
know.
asking it to send you stuff that you find interesting and it finds things interesting,
Yes.
it could miss, the little green man walking by.
Hopefully not, right? But
Yeah, hopefully not. Yeah.
you're absolutely right. You take the risk of, missing discoveries, right? Discoveries are often things that are unexpected in science. We weren't looking for or necessarily expecting to see huge volcanoes on Jupiter's moon Io when the Voyager
Yeah.
mission flew past, for example. We weren't expecting to see giant glacial mountains of water ice on Pluto when New Horizons mission flew past, right? So yeah, you do take that risk, which is why I personally think it's important to try to keep people in a loop as much as
Yeah.
possible,
Yes.
especially when you're talking about exploration, discovery. I mean, I'm trained as a geologist. If you go out into the field, sure, you're documenting things and taking pictures and making a map and all that, but sometimes it's just gut feel. Sometimes it's like, oh, something's not quite right here. I've seen 12 examples of this and I'd never seen that before, right? And so you're compelled to go over there and chip at those rocks, bring them back to the lab, whatever. So that serendipitous, unexpected aspect of discovery, I don't know if we can build that into AI because it's built into this computer.
It's built in, yes. And we need to figure out how to go find the stuff, but also be open to it. It's, AI is only as good as its coder.
Yeah. Yeah.
So
For now.
can you give us some insight into Mars rovers and what we've learned about the red planet?
Absolutely. Mars rovers have been continuously exploring the planet for more than 20 years. NASA continuous Mars rover presence on the red planet, Spirit, Opportunity, Curiosity, and Perseverance. The latter two, Curiosity and Perseverance, still operating great. They landed in 2012, Perseverance in 2021. And they've really given us the ground truth that came from orbiters before them. Orbiters are mapping the surface, just like satellites map the surface and atmosphere of the Earth. They've been doing that at Mars for decades. In fact, the Mars Odyssey orbiter, NASA's Mars Odyssey, just celebrated its 25th anniversary on Mars just yesterday. So these orbiters have been providing this sort of global perspective, and the rovers get down on the ground and give us the ground truth. They are avatars for us as geologists, as atmospheric scientists, as explorers with mobility and a limited set of senses like we have eyesight, smell, and taste through chemical and mineral instruments, legs through their wheels, walking around. So they've given us the ground truth to tell us that indeed Mars was a lot more like the Earth a long time ago. There were rivers flowing across its surface. There were lakes, ponds, maybe small seas. There was deep weathering of that surface. Clays and other water-bearing minerals are still there in the crust. Yes, there was a lot of volcanism, volcanic eruptions throughout Martian time. Yes, there were a lot of impact craters. Mars is covered much more so in impact craters than the Earth, so the surface has been less dynamic than the Earth. So almost all of Earth's impact craters have been eroded away or swept away by plate tectonics. But Mars preserves a lot of that early evidence of the earliest times in the solar system that are very hard to find on the Earth. And during those early times, it was a much more Earth-like planet. So what happened? Did life develop there? What happened to that thicker atmosphere? What happened to that more Earth-like environment? I don't think it was ever a tropical wonderland. Nobody thinks that because it's farther from the sun, so it's just intrinsically colder. But there was liquid water on the surface for long periods of time. The Perseverance rover just drove up over a delta, a river delta, like at the end of the Mississippi River. with beautiful sedimentary rocks in it, right? And these are the kinds of places we send those vehicles because on Earth, those are the kinds of places where you can see evidence of the habitability of our planet, mostly through fossils, but also through chemical and mineral signatures. So we haven't found any fossils on Mars, although of course we look. Haven't
Yeah.
found any of those little green men you talked about walking. Look,
Yeah.
we haven't found them. But we have found some chemical and mineral signatures that
Do
a lot like what was happening in the early Earth when life was just getting started producing certain kinds of chemical and mineral reactions. So that's super exciting.
When do you think we will go to Mars, and how long will it take to get there?
More great questions. You really start with the simple questions, right? Simple answers. Yeah, I wish.
Because that's the question everyone wants to know, right? When are we
No, of
going to
course.
Mars?
Of course. Well, it depends on my answer depends on who we are. For example,
I'm
the
not
China
going.
yeah, for example, the China National Space Agency has announced that they want to bring samples back from Mars and send people to Mars in the early 20s. That's very ambitious, very aspirational, but over the past few decades in space exploration, the Chinese have done what they said they were going to do, right? They landed a rover and a lander on Mars the first time they tried. Learning a lot from NASA's experience, of course, because we put it all out there. Lots of it's public. So they've certainly had their sights set on it. NASA doesn't have a specific plan. Partly the Artemis mission is part of what they call the Moon to Mars initiative. And I agree with the idea that, boy, wouldn't it be great to relearn how to live in space, spend more than 50 years, spend a bunch of time there, learn how to live on a planetary surface. The moon is right here. It's a safe harbor if something goes wrong, only a couple of days to get home, right? It's a great place to practice building settlements, trying to live off the land with the ice and other mineral resources in the lunar soil.
I'll say this. I understand why we would go to the moon, right? You could create a whole data center on the moon. You can send solar power. We don't need to use electricity. These data centers that we need to Earth, it takes a lot of power. And that's a great place to put it in on the moon. What's the purpose of going to Mars?
Yeah, well, first of all, I disagree that the purpose of going to the moon is to put data centers on the moon, right? The purpose is to establish an outpost for humanity, just like Antarctica, for example. Why do we go to
Okay.
Antarctica? Right? Because
Okay.
there's cool science to do down there, because it's the end of the world, and all the societies on the earth who regard themselves as leading in technology and science want an outpost at the end of the world. And here, the moon, boy, talk about the end of the world, right? It's way out there. And there's great science to do on the moon and all that kind of stuff. And it's practice for Mars. Why go to Mars, right? Well, it's the next frontier, right? If we've been to the moon, I'm not saying we shouldn't go back. We went, we planted flags, we came back, right? Let's go back and try to stay in that environment for a long time and really learn how to live and work and play in space. Let's really learn that on the moon, right? But if the Chinese go back next before we do, they're going to find American flags on the moon, right? Because we've been there. Nobody's been to Mars. That is
Okay.
next goalpost, right? So part of
Okay.
it, international bragging rights, prestige, national prestige, inspiration for the citizens of the nation or nations that make that happen, right? Partly. And partly it's because we can only do so much with these robots, right? A person on Mars, a trained geologist or a trained engineer, could do much more in an hour than those rovers do in weeks and weeks and weeks, right? Because they're machines and they're limited and they're guided by those of us back home, and it's a long communication delay and all that kind of stuff. So getting people into that environment will be incredibly impactful for the science, for understanding what Mars was like. Why did it change from an Earth-like place to the barren and dry and lifeless, apparently, world that it is today? Is there life in the subsurface? Is there microbial life underground where there are aquifers and heat coming from below, just like on the Earth? So I think it's going to take
What do you imagine the atmosphere of Mars is like?
different. And so we don't actually need to imagine it. It's been measured. It's almost all CO2. It's a little bit of nitrogen, a little bit of argon, tiny, tiny amount of water vapor. So there are some clouds, but it's not very much. But it's about the same pressure as like 85,000 feet up in the stratosphere of the Earth. So it's a
Okay.
very, very thin atmosphere, not breathable, and likely much thinner than it was a long time ago, because it's Right now, if you were to bring a glass of water, put it out there, that water would literally boil off into the atmosphere. The atmosphere is too thin, it's too cold. But there were rivers and lakes and small seas flowing on this planet a long time ago, 3, 4 billion years ago, early in the history of the solar system. The solar system's 4.5 billion years old. The sun and all the planets formed around then. And early in the history of that solar system, Mars had a thicker atmosphere. Where is it? What happened, right? This is a planetary scale mystery, right? And when we talk about trying to understand climate change on the Earth, here's a planet right next door where it's something dramatic has happened in climate change on a planetary scale. And by the way, if you go the other way to Venus, same kind of thing. Almost all CO2, 90 times as thick as the Earth's atmosphere, clouds of sulfuric acid. What happened? This is
Yeah.
basically the same size planet, basically in the same place in the solar system, basically the same material that the Earth has, and yet it, crazy greenhouse effect on Venus. So, our neighbors are telling us something about ourselves. And so I think it behooves us to explore
To
these
learn
places
it.
as much as we can.
Is there gravity or only Earth has gravity? Or we don't know?
Anything with mass has gravity. You and I have gravity,
Okay.
man.
Okay.
So on the moon, it's 1/6 of the Earth because the moon is smaller. On Mars, it's something
Okay.
like 3/8 of
Okay.
Earth's gravity because Mars is a smaller planet. Venus is about the same as Earth's gravity because it's about the same mass.
And then, so where do we go next in space?
Yeah. Well, I want to see a balance of both human and robotic exploration. And I want to see that. And that's been the hallmark of NASA has been a great mix of doing things with humans, with people, astronauts that are worthy of risking lives, and then doing things, going places where people can't go yet, and doing things that people can't do yet with robotics. And in the past 60 years of NASA doing that, we have studied our solar system and cataloged it. We know what's out there, right? When I was a kid, the planets and their moons in the outer solar system were dots in telescope pictures, right? Now they are worlds with character and geology, and some have atmospheres, and we've landed on some of them out there. And so I would like to see us as a species continue to rewrite the textbooks. We flew by Jupiter and Saturn with the Voyager probes, for example, and then followed them up with orbiters that spent a long time in those environments and really got to know the places and rewrote the textbooks. We haven't done that with Uranus and Neptune or Pluto or other distant worlds. And there's so much to learn with Mars and Venus as our planetary companions I just talked about. The moon itself is fascinating geologic history, and we have to find those icy resources and figure out how to extract them. Asteroids, there are asteroids out there with rare earth elements and precious metals that if we could figure out how to mine them, and asteroid mining is something people think about, right? But it's right now, it's kind of science fiction. If we can actually figure out how to mine them instead of just prospecting for those materials, then we would solve all the problems with rare earth elements and precious metals on the earth, right? They're out there. And so there's so many paths that we can take. I've been talking about ones that are kind of science and engineering focused, but what about tourism?
Yeah, that was my next question. How far are we from space tourism? Should I pack a bag?
Exactly. It's a great question. I told my kids for my 100th birthday, don't go overboard. Just a weekend on the moon. That'd be fine. Just a week. And so, and in fact, I wrote an entire book about this called The Ultimate Interplanetary Travel Guide. It's like a photer's guide set a couple hundred years in the future, imagining you have a weekend or a summer, you want to go explore Mars, the moon, or fly through the clouds of Venus, whatever. But I think that's coming. It's going to start in low Earth orbit. And we've already seen, of course, billionaires buy tickets on Russian launchers and spend time in their space station. And right now it's out of reach for average people. But 100 years ago, air travel was out of
It was
reach,
out of reach.
right? And it was just billionaires, the equivalent of billionaires back then, rich flyboys playing in crazy machines, right? And so with government investment, helping it become more safe, seeding companies with strange names like Delta, and United, and TWA, right? In a few decades, that became a real industry, a commercially successful enterprise that then gave access to the air to middle class people. And I'm predicting the same thing with space. It's going to take decades, right? There's a lot of safety issues. It's kind of incredible when you think of what happens when an airplane takes off and what's happening in that jet engine. It's violent, but accidents are incredibly rare. So,
Well, it's dangerous, but it's very, as you said, it's very rare.
yes. And so rocketry is also dangerous, right? Traveling in space is dangerous. If you go somewhere in an airplane and you land, when you get there, there's oxygen at least, right? How about that? I
Yes.
can breathe. That's not true in space travel, right? So you got to bring that stuff with you or make your own oxygen, your own fuel, grow your own food, if you're going really far away. So there's an enormous amount of infrastructure that has to be developed. But I see it coming. I see tourism is a great business model on the Earth, and I think it can be a great business model in space for the decades ahead.
Before we wrap up here, but do you think they're aliens or that they're here, they're watching us? It's a question that I just,
Asking two different questions, right? And I'll answer the first question first. Do I think there are aliens? I can't help but believe, just based on the numbers, that there must be other forms of life out there. And a microbe on an Earth-like planet around a nearby star, I consider an alien, okay? We haven't discovered them yet, but what we have discovered is that the ingredients for life, the chemical elements, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, the things on the periodic table are everywhere in our solar system and in other solar systems, that stars like the sun are very common, that in the past few decades, they have planets around them. Some of them are Earth-sized, right? We've discovered these things, right? The periodic table is the same here as in a nearby star, as in the Andromeda galaxy, right? And so it's all the same physics and chemistry, right? These are universal. Mathematics, these are universal, literally. And so given that, by some estimates, there may be at least 10 million Earth-like planets just in our galaxy. I think it would be the pinnacle of hubris to say there's no other life out there, right? The problem is the distances. And the problem is Albert Einstein's stupid speed of light, right? That's the problem. Communication and travel across the vastness of space might prevent us for some time or forever from knowing what else is out there. Your second question, are there aliens among us, living among us, studying us, probing us? I don't know. I'm a scientist. I would love to see some evidence. Everybody has cameras now, right? Where are they? Where are they randomly in people's film? Are they that smart to delete all of that? Maybe. I don't know. I'm evidence-based, evidence-driven, and I don't want to see crappy, fuzzy evidence, right? I want to see real evidence.
Evidence, yes.
And look, I would love to believe it. I think every scientist out there would love to believe that there's intelligent life out there that is somehow in contact with us. They haven't eaten us and they want to help us, right? That'd be great. I'd be at the front of the parade, right? But we are also evidence-based kinds of people.
Well, we can't be the only ones. I always think we can't be.
Seems to be true for our solar system, at least. Right? It seems Earth is a very special place. There's nothing like it. We explore space not to find other places for the human species to live. There's nowhere is going to be like the Earth, right? Yeah. But if we could travel to other stars, if we could send probes to other star systems, we know that even the stars near the sun, near in quotes, still a long way, many, many, many generations to travel there. Even the stars near the sun some of them have Earth-like planets. So yes, you're right. I think the numbers argue that how could we possibly be alone? But it's frustrating to think that we might never be able to know.
And as you wrap up, is there anything I should have asked you that I did not ask you?
I think you've asked some great questions, and I appreciate you keeping the topics very simple with clear, obvious answers. No, I think, this is something that a lot of people care about, right? People support NASA, people support space exploration. In the US, less than a half a penny of everyone's tax dollar goes to all that NASA does, right? And the exploration part of it is much, much less than that. So a lot of people think we spend a lot of money on space exploration. It's a tiny, tiny fraction of our immense wealth that we have decided as a society, this is important to do. It's important for our kids, for our teachers, for science, for the nation, right? And I'm really happy I live in a country where we decide to do that and get excited by these things.
It is fun to get excited by this stuff, and it is really exciting to learn about it. Jim Bell, thank you so much for joining me today. The book is The Art of the Cosmos. You can get that where you get your books. As always, let me know what you think. Put your thoughts in the comment section. Until next time, everyone, be safe.